Okay, welcome back. In this video, we're going to do a problem similar to one of your homework problems, which is you're trying to find a geometric sequence where it gives you two terms of the sequence. And this is the same example that they have in the book. The numbers they chose are rather messy, but I'm going to go with them anyway. But essentially, we're looking for a geometric sequence where the third term is 63 over 4 and the sixth term is 1701 over 32. Isn't that just the best thing you've ever seen in your life? Um, so, the idea here is that we want to find an equation for the geometric sequence, right? Um, I think in some of the ones in the book, it's just asking for a specific term of this sequence, but we'll find the equation, and then once you find the equation, you can find any terms that you want. So, so A sub n, remember, with our geometric sequences, is going to look like that form that we had. So um, it was okay, so A sub n is A times r to the n minus 1. That will be the form of our equation, right? And so then we just have to figure out what A and R are. So this is what we're trying to figure out, A and R. And it tells us two terms. It tells us the third term is 64 over, or 63 over 4. So in other words, when you do A sub 3, when you replace 3 with n, you should get 63 over 4. And A sub 6, the sixth term, when you replace n with 6, you should get 17 over 1 over 32. Okay? So essentially, we're going to do kind of a similar thing to what we did with the arithmetic sequences. We got, we're just going to plug both of these in. So I'm going to plug in 3 for n into this equation. And I get A times, well, 3 minus 1 is 2. So this would be the same as A3, right? AR squared. And this would be equal to the 63 over 4. Okay? We do the same thing with 6. Plug in 6 for n in this equation. We get A. Well, 6 minus 1 is 5, so r to the fifth power is equal to 1701 over 32. Okay? Now, kind of the trick here is we want to find A and R, and this is a nonlinear system of equations because you've got variables timesing by each other, right? And so in order to get rid of this A in here, I mean, there's several ways that you can solve this. Maybe the easiest way is like with a substitution of let's solve for A in this top equation because solving for R would be a little bit more difficult, and then we'll plug that A into the other equation. Okay, so I'll do A equals 63 over 4, and I'm going to divide on both sides by R squared to get rid of that R squared. So I would just move the R squared into the bottom. Okay, so that was me solving for A from that first equation. Then we'll plug that in for A in the other equation that we have. So we have 63 over 4 r squared. That was what A was, so that's the first thing there, times r to the fifth, and that should be equal to 1701 divided by 32. Okay? So now we've got something that we can deal with. We've got this r squared and this r to the fifth here. Those are on opposite ends of the fraction, so they're going to cancel, and you'll be left with an r cubed. So in other words, you get like 63 over 4 r cubed would be equal to 1701 divided by 32. Okay. Then to get rid of this 63 over 4, I would flip it and times on both sides, right? So times by 4 over 63. That would cancel it out. So I'm going to be timesing this one by 4 over 63 as well. Let's see. So we're going to be doing 4 over 63 times 1701 over 32. I'm going to just throw that in the calculator because I don't want to deal with that. Okay, so I got 3.375, which I think is 27 over 8 as a fraction. Okay, so how you could get that is 63 goes evenly into 1701, it turns out. So you do 1701 divided by 63. I hope the numbers on your test are not this terrible. But 1701 divided by 63 is this 27, and then 4 goes into 32 8 times, right? So the 4 cancels up top, and you're left with 8 still in the bottom. So this would be our fraction there, 27 over 8. And remember, this was equal to r cubed, okay? So then how do we find r? Well, I'm gonna maybe move this so that we got some more space. Okay, so how do we find r? Well, we take a cube root on both sides. So r is the cube root of 27 over 8. The cube root of 27 is 3, and the cube root of 8 is 2. So my r is going to be 3 over 2. Okay. So now to find a, or we found r, right? That's one part of our issue. The other thing we've got to do is find a, right? So I would just plug that r back into one of the equations. I'll maybe do the first one. So we get a times r squared, so 3/2 squared is equal to 63 over 4. So we've got a times 9 over 4, 63 over 4. To get rid of this 9/4, I'll times by 4 on both sides to get rid of the 4 on the bottom. But that'll cancel out of both sides. So just times by 4 on both sides will get rid of that 4 on the bottom. So we get 9a is 63. Then we just divide by 9. So a is 7, I think. Yeah. 7 times 9 is 63. Okay. So we got that a and we got r. So now we just use our geometric sequence formula, which was this an equals a times r to the n minus 1. So an, in our case, a is 7, right? And then r to the n minus 1, well, r was 3/2 to the n minus 1, right? And that's our equation for this geometric sequence. And if we wanted to, we could find any term from this. Like you could, if you wanted to find the fifth term, right, you could plug in 5 for n and then find out what it is. So anyway, this is how you would find a geometric sequence just based on two terms. You really only need two terms, and you can find the entire geometric sequence. Okay, so I will see you guys in the next video. What we're going to be doing next is kind of like what we did for arithmetic sequences. We looked at the sequence of partial sums, so that's what we're going to be looking at next.